Hello, everyone. This is a review of some key concepts from linear algebra for use in Math 465/565. I'm going to start with background and setup, but first, some motivation. Numerical linear algebra is really one of the key pillars of computational math, and this is for two reasons. It's that many problems in the applied sciences, they involve vectors. They involve the need to process multiple types of information, and they're not scalar valued. Furthermore, nonlinear problems appear all over the place, but when you encounter a nonlinear problem, typically what you're going to want to do is you're going to want to approximate it by some linear problem, so linear methods still become really useful. There are four main big problems in numerical linear algebra. The first two, which we're going to focus on in this class, are solving large systems of linear equations and least squares problems. The other two are finding eigenvalues and singular value decompositions. Getting a bit more into it, a linear system is a system of m equations with n unknowns that can be written like this. There are n unknowns, which are x1, x2, x3, all the way up to xn. In front of the x's, there are the aij's, which are called the coefficients. And there is the right-hand side, which is given by b. There are three basic types of linear systems. If the number of equations is equal to the number of unknowns, i.e. m equals n, we call this a square system. In the case where there are more equations than unknowns, m greater than n, we call this an overdetermined system. On the other hand, if the number of equations is less than the number of unknowns, we call this an underdetermined system. It's going to be convenient to describe these things in terms of matrices and vectors. A matrix is essentially a table or a giant rectangle full of numbers with m rows and n columns. Typically, the matrix itself is denoted by a capital letter, and the coefficients are denoted by lowercase letters. And if we want to indicate that this is a matrix with every entry is a real number, we write that A is in R m by n. Whereas if it was complex numbers, we'd write A as in C m by n. Common shorthand is to write A equals this collection of the aij's. We might also use MATLAB notation, where, for example, A24, 35 means we would grab this slice from the bigger matrix corresponding to columns 2 through 4 and rows 3 through 5. If a matrix only has one row or one column, we call it a vector. So a column vector is going to be a tall, skinny vector like this, whereas a row vector is short and wide. If we talk about an entry in Rn, this is assumed to be a column vector. If we want to specify a row vector, we'll write x in 1 by n. Lastly, for a matrix with m by n entries, the transpose is the matrix you get where you flip it on its side so that the rows become columns and the columns become the rows. So for example, this entry A12 that's in this position here, in the transpose, it goes to that location right there. Note that the shape of A transpose becomes n by m rather than m by n, and then if you transpose something twice, you get back the original matrix. So that's it for this video. Up next will be matrix and vector operations.